and we have nice team. So I think almost everybody know each other, but let's maybe start from short introductions.
Sure, I'm Vadim, been around FHIR for a fair bit, currently working with Philips as a software architect, and also wearing my own hat as a FHIR consultant.
Thank you. So next is me. So I'm Nikolai, I'm CTO of Health Samurai. So we are crafting FHIR backend on Postgres. And next, Craig.
I'm founder of CQLab. I'm doing a lot of work with CQL and different clinical decision support engines for using FHIR.
Thank you. Dan.
Dan Gottlieb. I've been working on FHIR standards for a number of years. I'm a clinical informaticist and software developer, currently doing consulting around a number of projects working with FHIR data and setting up FHIR data stores and that kind of stuff.
Thank you. Ryan.
Hey everyone, Ryan Bashir. I'm a software engineer at Google. Previously, I've jumped a couple of places over the years. I was at Cerner many years ago, where I took the initial pass and worked with Nikolai and others at some of the SQL on FHIR stuff. Then spent a few years doing some totally unrelated things, mostly working within like Google's research to try and get healthcare data working well versus with some of the ML AI capabilities. And so I kind of disappeared for a bit from the SQL on FHIR space, but I think I'm going to be increasingly working on that space again going forward, just because it's sort of a nice sort of complementary capability there. So yeah, still with Google, but and plan on continuing here, but I'm excited to kind of get back into this area that I had stepped away from. I honestly did miss it.
Thank you, Ryan. Nice to see you.
Brian Kaney, I guess a full stack developer.
Okay, nice. Ivan.
Hey guys, my name is Evan. I'm the digital engineering lead at NCQA. I'm currently doing a bunch of stuff related to CQL, most exciting of which is I'm digitizing HEDIS. It's a major factor in the healthcare market in the United States, big business. And I also work on a software product that computes measures at scale on the cloud.
Thank you. And Bashir.
Hi everyone. I have met some of you, but I guess most of you I have not, at least in a meeting setup. I am Bashir Sadjad. I work in Google, mostly working in the healthcare space in the LMIC, like developing Word basically. I have worked with Ryan a lot. We have inherited Bunsen from Ryan's work in Cerner. We use it because we work on open source projects. There are two main projects that I am responsible for in the FHIR space. I have been working in this space for almost like 3 years. I started the work with the OpenMRS community on their FHIR interface, and also we built the original analytics engine that we currently have for OpenMRS, but with FHIR as the interface, not the OpenMRS data model. And so that's one of the things that I work on, and that's why I'm here. And the other piece from the Open Health stack that we have 3 components. The other component that I'm responsible for is FHIR Gateway, is basically like an access proxy, which we have also open sourced. So yeah. Nice meeting everyone.
Amazing. Nice to meet you. And just for fun, I think everybody knows Josh, but Josh, do your intro.
Hi, I'm Josh Mandel. I'm a physician and software engineer, the chief architect at Smart Health IT and at Microsoft Healthcare. And yeah, have been working with Dan over the years on bulk data, and really interested in seeing how folks can start making better use of these exports that are happening.
Thank you. So, okay, let's start. I will share the screen. So I created the short agenda. So the first of all, so we have a author of the SQL on FHIR version 1, which we can call, I don't know, tabular or columnar or binary SQL on FHIR. So, and I think this is a very interesting how to discuss how we can try to unify and merge these 2 specs. So the first question for discussion is Do you see that potentially that then can play together, or let's say that the binary columnar version can be built on top of JSON stuff and share most of transformation and approaches? So, and it would be nice, yeah, if you share your opinion about this.
I guess I can go first since I stirred up some of the conversation in this space. So yeah, I think that there will be a fair amount in common between the two, and I think in some of the forums, I think actually it was Dan who originally had this suggestion of identifying the common set of transforms to an SQL model that would apply to both both like a native or columnar representation and a JSON representation. So things like extracting like record IDs in a way such they're much more easily joined and that sort of thing. And I think there's a list of those things that are common to that. So I think part of this group, over the coming weeks, would totally make sense to me to kind of work through and identify that set of commonality and kind of try to record that in a common place and work from there. I think that in terms of like building on top of it, I think it kind of maybe depends on exactly what that means. There's like some subtleties there with regards to like a columnar store. So if we're thinking from like a systems architecture perspective, I mean the columnar data model really requires the data to be stored in a very specific way. So it couldn't be layered physically on top of a JSON layer. But I mean, I think that there is certainly a significant common piece to it that both would use. And I think that'd be great to kind of put that together and then reference it from both sources and be consistent there.
Mm-hmm. Thank you.
I think just kind of Ryan and Nikolai, I'm curious about your thoughts on this. Like, it seems like most of the columnar representations are somewhat lossy, so you kind of have to make decisions about like levels of recursion at the very least, but probably also like which extensions to unbundle and put in a tabular structure, and similarly with like codable concepts, how many you want to spread out, because your rows kind of explode as you take the deeply nested FHIR stuff and flatten it. And so I guess in JSON, maybe you could do either. You could kind of go either way, right? You could simplify your JSON to make it less easier to query, but maybe losing some of the FHIR detail, or you could do transformations that are in JSON at least, keep kind of all the original data. And so I think one thing that would be good for us to kind of say on the outset is how we're thinking about like what our use cases are, and how we're thinking about lossy versus kind of storing the entire FHIR data set, because I think that'll maybe inform some of our decisions around what the spec looks like.
Mm-hmm. Yeah. So
yeah, and you're absolutely right that there are some things that are not like easily or impossible. I mean, you can't an SQL native data model doesn't typically have like arbitrarily deep recursive structures like you could have in FHIR. I mean, and so yeah, there's some like workarounds to that. It's like we've done some things where we would like scan the data set and then find like, hey, what's the deepest recursive structure, and generate a schema that pursues that. So we can consider that sort of thing, but at the same time, I think it's okay from a columnar perspective, because even if it is, I mean, our mental model is the view of the columnar data as logically like a view, and maybe it's like a materialized persisted view of the actual FHIR data because it is lossy. But that sort of materialized model obviously has some really nice performance properties when querying, so I think it's worth having. But I will acknowledge that, yeah, in practice, yeah, the columnar or the native representation, there is a lossy element to that, and so I think this is maybe something we should be exclusively clear about. And from a JSON perspective, I mean, I think it's entirely justified even to keep a purely lossless model. Everything is there just because I think that's what most users would expect. So I think that maybe that's just a trade-off that we have of others.
Mm-hmm. Yeah, and I would say that we can think about what objectives we're trying to achieve. Yes, so we have quite clear goal. Yes, so that's kind of ideal goal, that we will have kind of portable SQL queries between different engines. Yes, so we understand the trade-offs of columnar model, like this recursive stuff, but it's still, we can try to achieve that 80% of queries. I don't think there's a lot of recursive stuff, yes, in analytics, so that we can try to achieve like 80% of queries can be portable or at least translatable between implementation. And that could be the nice goal. That's why I'm talking that if they are unified, because the most of transformation are quite similar what we discussed at the first version, yes. So it's the same. It just made it simple to query through what we have in SQL, yes. And that's, I think, another topic to discuss, how deep we want to go with all these transformations. So and what the principles we can use. For example, I did a review of, or maybe somebody else want to talk about the columnar versus JSON. I don't know.
Well, and Nikolai, like you said, I think a big win would be to make it easy to write these queries, you know, as easy as possible, to get more people writing them so that they make sense. And you're obviously going to have very different queries using the JSON's columns and the tabular, right? All the relations. So those are going to be very different queries. And unless you have some kind of SDK in front that's building the different queries based on how you're using them, you kind of have to, the queries you write directly in SQL are only going to work on one of those types. And it's possible that one's going to be a lot easier to read and easier to write as well.
Mm-hmm.
So I have one thought on that. I'm curious about other views on this too, but like, I guess one option would be to kind of have a layer in between. So kind of, if we're talking about like an analytics query, you probably are using maybe multiple tables from the columnar representation, and you know, maybe multiple resources on the, or you know, different however you do that, different tables or resource type column, but multiple resources on the JSON side. And so you could kind of pull both of those into an intermediate representation. That's the columns you need for the query, and like a flattened view, like a just-in-time tabular view of the JSON, and then kind of build your complex logic, the, you know, quality calculations, the aggregation, the reporting on that layer. So I could almost see like kind of two different bases with similar transformations that could be queried directly, and then maybe some intermediate representations that are use case specific, that could be just views or even just queries. And then on top of that could be the real portable kind of more complex queries. Yeah. But you know, so I don't know, that's one way to kind of try to address the point you're bringing up, which I think is really key, which is that, you know, a query on JSON with path statements looks very different from a query on a flattened tabular structure. And so like, I don't know that we have portability at the base level, but maybe we could have higher levels that have more portability.
Yeah, but we have a dimension of transformation where we can try to transform FHIR that way that like the basic queries will work for both, yes, for the columnar stuff, tabular stuff, and for JSON. And yeah, and I my vision, like, so having this basic representation of recursive data structure like FHIR, yes, nested, let's say nested, not recursive but nested. Yes, and then we see how popular DBT and Looker and stuff like this. So, and we can kind of, if we will have kind of at least portable queries, then we can define the views and share these views. Yes, and
yeah.
So that could be the pipeline which SQL and FHIR can provide.
Yeah, it's kind of what we talked about last week, was this idea that, you know, I'm not a Cortex and analytics type guy. I don't do any much code in Power BI, right? But I do know that at NCQA, for example, we have a data warehouse, and the guys who write reports, they write views, right? So what we're kind of talking about is, as long as we have a somewhat common underlying data structure, if we decide to use JSON columns for that, then it should be possible for us to define views, or for other people to define views. If they decide, you know, I really do want a relational schema on top of this because I have some tool that I use that only supports relational and doesn't support JSON syntax, so I have to create these views that I put in my own database that enables this for my own tooling, then that should be a use case that we support. right? And we should have guidance on how to do that, what it looks like, examples, and so on. And then we can also offer canned sets of relational schemas on top of our core. As far as the transforms from pure by the book FHIR into database friendly FHIR, it would be nice if we could do it entirely within the database system itself, as in like a stored procedure or a function or a table valued, whatever it looks like. And it may differ from platform to platform, but that would be nice, because then you could just simply dump the FHIR as is into a database and then, you know, run a stored proc or something to load it into the schema that we care about. That'd be cool. The more external tooling we need to sit in between the FHIR that comes out of, like, I don't know, a bulk FHIR query or something, and this database schema, the harder it's going to be to drive adoption. Because if we say, oh yeah, just run this JavaScript thing. Well, now from an operations perspective, now I have to figure out, I got to launch a node server to do that. How do I integrate that ETL into this whole process? It adds cruft to it. Whereas if it's just, yeah, go ahead and dump the raw FHIR into this column, this table, and you know, run this sproc or something to turn it into the transform we want, into the form that we're talking about. That would be cool.
Yeah, I'm pretty sure that we would be able to define very useful flattened views like pre-aggregated. Yes, because
yeah,
like aggregating passion with the observation, flatten all of this, and this view will be used by. But it's going to be lossy. That's why it would be nice to have lossless representation, almost lossless. Yeah.
Yeah.
And then on top of it, create some more convenient tabular views. Yeah. Right.
Yeah. So first of all, strong agreement with the pattern of like, you start with the rich FHIR data, then create some sort of tabular views on top of that, and then do your complex analysis on top of that. I think sounds like multiple folks on this thread have kind of independently kind of worked their way there. It's just a good way to do things. And also, definitely agree with the point of we don't want to have ideally, we want to have like a ton of like sort of intermediate services in there. I mean, it's so if you could do it in like native like SQL views. So I know like most SQL engines have like a virtual view that will be just automatically updated when the underlying table is updated, and it doesn't. And so once you run your create view statement, you don't have to have additional services there. The view is your nice tabular view is updated. So I think that pattern makes a great deal. I think that pattern makes a great deal of sense. And so I think that underneath this, so I think that the area where things get a little bit more involved is like as we go down the layers there, and this is where I'll kind of represent sort of the columnar angle on this because I'm more familiar with it, is like, we've used this exact same pattern for use cases over columnar data. And the nice thing about that pattern, specifically over columnar data, is like all the optimizations that you get in the views are applied by like the super efficient scans at the base level. And so it's if I can create like a view. If I have a table of 1 billion observations and I want to create a view of like, say, only hemoglobin levels, I mean, there's a really super efficient like filter and that sort of thing that can be done. So even though I have this nice little table, I got to get those optimizations. So that's a property that I think for some use cases would be important to preserve. So I think that it may be difficult to find like a common like SQL for the loss for that sort of base layer there. However, to the extent that there are common simple tabular views to work with, I think that would actually make sense. I suspect there might be different SQL to create those tabular views from the JSON model as we would see from a columnar native model. But one, I think it makes sense to reuse as much conventions as we can, even though I think there will be differences. And two, if there is like reuse of like, there's a common like hemoglobin table that's useful for a lot of folks for a lot of analysis. I mean, maybe we can define those schemas and work with that. And I'll just add one more comment to that. I think that the only challenge I do see in that space is that every use case is going to have like a kind of probably different demands of what their flattened data looks like. And so I think identifying something that's broadly reusable in terms of these flattened records may be a bit challenging. And so it may be something we need to tailor per use case. But I think Josh raised his hand.
Well, yeah, Ryan, your last comment really picked up on what I wanted to ask about, which is, are we talking about essentially use case specific SQL tables here? Because I agree that might be very practical, and there could be actually better value in that than anything else we're going to do, depending on how effective we are. But it's ultimately like a very similar problem to trying to get consensus on, a firework group. Like suddenly you don't get this sort of agnosticism of like, okay, I'll take advantage of all the data we've got. Different people will come later and ask different questions. So if we wind up going that route and really focusing on, a common set of useful squarish tables, is there still a piece of this project that deals with, the general underlying structure, or does that wind up just getting kind of pushed into the database specific concerns?
That's a great question. Yeah, I think either one's entirely reasonable, and I would be open. Yeah, I would love to hear others' perspective, but I'd be open to either path out there.
So I drew a diagram that might lead towards how I was trying to think about this problem, and I've only really been thinking about this for a week, and I'm also not like a deep SQL expert. Would it be okay if I shared my screen for a moment? Yeah. Unless Dan, your hand's still up, and did I butt in front of you?
No, we can jump back in to the other discussion afterwards. I guess I just one quick point on what Ryan and Josh were saying, and then we can. I really do want to see your diagram, which is just that I wonder if from a spec perspective, it might make sense to try to define like the lower level transformations and kind of some of those base tables. And then maybe we define some namespaces for the use case specific, or sorry, not specific namespaces, but like a namespacing approach for the use case specific table, so that those could kind of get layered on, so that, if we have a whole series of tables around, let's say, HEDIS measures or something like that, there's a standard way to make those make those table definitions portable and define them in a way that won't conflict if people have multiple of those tables from different subspecs. But at the base level, those could all be pulling from some set of standardized resource level tables that have transformations applied, and those may sit on either JSON or directly loaded flattened data, depending on how that's done. So I don't know, one thing to think about, sorry about that, Brian. I just wanted to get that in before we moved on, but yeah.
Can I talk a little bit? Yes. So I keep in mind the DBT, which is quite popular. So potentially we can provide maybe even just DBT tools, so people can publish this flat and useful views. And ideally, if we will get to the point of portable queries, so these views can be built in different databases and used, and they can be. So we should provide, I think, tools and conventions how to build these views. They could be namespaced. Probably we can even leverage DBT stuff to describe all the, or maybe, I don't know, FHIR structure definition to define these views and plus SQL.
And that's exactly where I see this project going, really. What we're trying to do is define the framework for mapping FHIR concepts to database schemas in a consistent way that can allow people to come up with their own schemas that they can publish, that we can all use because we're implementing this common base structure. That would be a great end place to go, because whatever use cases we collectively as a group come up with, that's just going to be, the surface above the water, and the iceberg is going to be a lot deeper than that. And if we produce a good framework that would allow people to create their own use cases and all that, I think we'll be very impressed at what the broader community could come up with that we're not going to think of. And so I don't want to be too prescriptive and think, well, we're going to enumerate all the use cases, work out exactly how those would work. And, unless you come to us and say, okay, working group, I have this use case, can you come up with something for us? We don't want that to happen. We want it to be more like the way profiles work in FHIR, where anybody can create a profile and share it and distribute it and make it work with the existing ecosystem. That would be, I think, the kind of holy grail of this project, is to create SQL on FHIR as a first class use case, which right now it's not, and it should be.
if this project was to say focus only on this view layer, right? And you could have a couple different, you could have JSON columns or columnar or variations in those. But we just said, hey, let's put out specs for the view layer. We create whatever queries we need to get the views in these various databases. Aren't we essentially just creating a new FHIR resources, a new standard that just is easier to query?
I would
We're
say
creating a profile of FHIR resources.
Creating a
that are
profile
easier to
that
query.
doesn't have weird extensions and choice types and things.
I would say we're creating a database-friendly FHIR representation and tooling around this, and then ability to create flattened views on top of this representation. So that could be the scope, like framework, how the set of transformation, how we can make FHIR more friendly to the database. And when you did this, so you can define flattened views, and this flattened views by use case, yes, can be published and shared in the community.
Yeah. So the material view, so kind of that use case you used, like let's say insulin, like a table for insulin patients. That would kind of be like a second level material view, right? So the first level would be this kind of flattened FHIR thing that's general, that can work anywhere. And then you can do whatever you want for your use case for whatever your health app is.
Something like this.
Yeah.
I'm not sure that we will get kind of generic flattened FHIR because it's impossible. Yes, FHIR is richer. You could not express FHIR as a flat stuff. So we are trying to represent it as a nested data, and then you can start building view layers on top. So and like in dbt, you can base your view on top of another flattened view. Yes, and aggregate, pre-aggregate, and do stuff like this.
Yeah. So I think we're almost out of time already. And I think, Josh actually brought up a great point in the chat of he's not sure that the generic flattened FHIR is feasible. Actually made something that I literally laughed at, and that are we building OMOP here? So I think I agree with those sentiments very much. Just like every use case that we've come across with has demanded some. Flattened views are awesome as long as they fit your use case, and every use case has different flattened views. To use a little bit of hyperbole there. So I think that we should invest. Yeah. So I think that there's some interesting challenges in this space that we'll need to work through. And actually, so we've been. One other thing that maybe we can follow up on subsequent meetings, like we've been experimenting with patterns to make it easier to just declaratively create flattened views. So and I know that like other folks, I know that like the Pathling folks aren't able to make it because of their time zone differences either. But a pattern of using like FHIR path expressions to select what columns I have in each flattened view, and then maybe a filter to say, hey, I want these columns, and I want to filter by hemoglobin observation code, and there's my hemoglobin table. So I think some pattern of like using FHIR path or something like that could make sense. But I do think that it'll be pretty difficult to find any common set of flattened views that would be generally useful, is my suspicion.
Yeah, Josh mentioned the OMOP. So my vision that it could be the first experiment using SQL on FHIR, try to define views which transform FHIR to OMOP representation. So as a set of transformations.
Well, there's OMOP.
Actually, that would be interesting. Oh, go ahead.
There's a project called OMOP on FHIR. I haven't looked into it myself. I'm just dimly aware that it exists. Because some people say, oh, I use OMOP. And I say, well, we use FHIR. So here, look at this project. It's OMOP to FHIR. Make it so, right? Are we trying to talk about doing the reverse, right? Is one of the views that we create, one of the use cases we create is to surface the OMOP schema by creating views into an underlying FHIR data store.
Okay, so let's get back to Brian. Brian, can you share your diagram? Sorry.
Yeah, so I was trying to find Dan's, it builds on the Dan Gottlieb multi-layer strategy, which I can't seem to find readily, but let me share my desktop. So basically, the idea is, if I can move all this stuff out of the way, like we have this is the Gottlieb multi-layer approach. So we have these layers, layer 0, 1, 2, 3, whatever, that define logical models. I feel like there's a specification part that might be the serialization. columnar, JSON, whatever, that's independent from the logical models, because the logical models are not the same as the strategy of how you serialize, and then the persistence is, however it gets persisted, and that's kind of not part of the spec either. But I feel like the spec maybe could indicate, and logical models are like how we represent FHIR in this kind of way that's more compatible with SQL. And I wonder if the kind of bounded context of what this project is working on is kind of like, wow, that didn't work the way I wanted it to. Is kind of like in this region here. Maybe it includes specifying these logical models, and then additionally how it's serialized, or maybe the serialization isn't part of the spec, and maybe that's just up to you. Is okay, I want to represent these as in a columnar database, or I like the JSON-B approach, or whatever. I'm not sure. And so what I spent a little bit of time on is, okay, just these logical models, like, and following kind of layer 0, where we talked about pulling out the references. I didn't attempt to represent anything on the like the contained resource, which I think was at that first level as well, if I remember that correctly. And so I just started, following Evan's guide on using institutional HL7 technology. I decided to make an IG where I just started using, very simply, like played around with this idea of using FHIR shorthand. And here I've modeled a condition, and a condition can have multiple references. And maybe this is flattened, and instead of just a reference being the name of the reference, the type, and the ID, maybe you literally put subject in the CQL condition logical model, or participant, or whatever else condition has for references. And so, yeah, this can build, I think there's you can visit this website. So it's starting to look like an HL7 thing, but if I look at condition, I could see like my, and these names, this is all just like throwaway. This is just a first pass at seeing what this might look like. I have a structure definition that represents a logical model called SQL condition. So this is the analogous model to a FHIR condition, where you might have its logical ID, its reference to condition. And again, how you serialize that, whether that's JSON or column, that's not part of the logical model, is how this gets serialized. And then one or more references, and the references are basically this kind of reusable logical model that has the reference name, the type, and the ID, something like that. This is really rough, really first pass. I was more or less just trying to see if it made sense, this thinking and using at least FHIR machinery to model the logical layer. I think the serialization, it might not make sense to shoehorn that into FHIR ecosystem, but I do think the logical models can be represented using structure definitions, which would make it maybe more appealing to the broader HL7 community.
Josh, you have your hand raised.
Yeah, so Brian, first of all, this is really like an interesting use of the machinery. And I guess when I'm looking at this, I sort of see it as a way to implement some of the decisions we might make in this project. But I guess it's me that
I can't hear you.
Josh, yeah.
He's going robot.
No one can hear you, Josh, and we really need to. Well, maybe we'll hear from him.
So
Yeah, the whole concern I have with not using the FHIR machinery is that this project is called SQL on FHIR. And if we spend too much time thinking about the SQL part and not enough time thinking about the FHIR part, then what are we inventing, right? Like, are we inventing our own thing? If we want this to be an HL7 working group and an HL7 initiative, and we want to get interest from people who are in the interop community, then we have to make sure that we integrate prior art. And if we don't, then we're really not, this isn't a working group, right? This is just a group of guys who want to make FHIR work on databases.
Group of people.
Yeah. Okay. But just using tools doesn't mean that you are.
No, so what we could do is we could say, now that we have a structure definition that represents the logical model for an SQL condition, and you joked about this last time, but you could define a structure map that some machinery could use to at least get it into that model, if that even makes sense. I think what Evan's saying is that if we're going to make a ballot and make this in the HL7 community and this gets officially balloted, I think I don't know how far we can go, but I think we can at least maybe represent these logical models using logical models. Right?
Yeah, I agree. So if you look into the draft spec at the bottom, so probably the view definition.
What does that mean?
Yeah.
This
at the bottom, yes. So the view definition, when we almost flatten FHIR, slightly up, so to the view, so can be described with a logical model. And
exactly. So we could use, actually the syntax in shorthand is actually nice, so it's almost the same, and that builds us fully compliant structure definitions for the people who like that.
Yeah, and if somebody use some code generations, so they potentially can generate code and use this flatten views.
Yeah.
Right, so I mean, a simple use case for why having a structure definition would be nice is that, for example, Gino's got a tool that will take a structure definition and generate C# classes. Okay, so then once you have the C# classes, you can just hook Entity Framework up to it, and now you can access the database through C#. There are tooling chains that want to do something like that. So people are investing in building tooling around the FHIR artifacts.
Yeah, and we use that same toolkit to make TypeScript definitions.
Right. So ORMs could use this straight out of the box. If they were structured definitions, you can take advantage of existing tool chains, which I think would be cool.
Then?
So I guess two things. One is that I guess one way I've been at least thinking about this project so far, and certainly, I think it could be broader than this as well, but is, kind of how do we interface FHIR into existing kind of data warehouse, data reporting, even data orchestration tooling. And so in some ways, when we talk about SQL on FHIR, my view is kind of what's the minimum number of alterations we can make to FHIR to interface, to kind of take advantage of some of these very scalable, very low cost, very widely deployed, very secure tools that already exist and are being used in kind of every other industry but healthcare. And they're being used in healthcare too, but just not with the FHIR standardized schemas, right? Everybody's got proprietary schemas for their data warehouse in healthcare, or commercial schemas. So I guess when we talk about SQL and FHIR, at least that's how I've been viewing it, is that we're taking FHIR and figuring out how to plug it into SQL while keeping as much of the FHIR data dictionary definitions, documentation that we can share. That said, I think Brian, your point and Evan's is really important, which is I think we want whatever we produce to be kind of familiar to folks who are living mostly in FHIR land and less in SQL land than some of us. And so I think there's probably, certainly a place for kind of some of this infrastructure that you're looking at around kind of codifying what we're defining in a way that's more FHIR friendly. I guess the one thought I had on that is like, I'm wondering if it's too early to start moving into the FHIR world until we define kind of exactly what transformations we want and what we want our output structures to look like. So I don't want to I guess I worry a little about being too constrained by how FHIR represents things rather than kind of just thinking about general use cases and how we want to represent them. And so somebody earlier, I'm sorry, I forget who, mentioned, potentially trying to support like in an ELT model where you kind of put the data in a database and do your transformations inside the database. I think that would be a really good thing to support if we can. And so I want to make sure that we don't get too involved in tooling until we figure out exactly kind of the structures we want to support. But
But
Well,
what
do
we,
you think,
Dan,
do you
when we
think
run
this
the risk,
separation makes sense, Dan? Like are you saying there's too much indirection here and we don't need to define formal logical models? It's all about serialization.
I guess I don't know yet, is what I'm saying.
Yeah, so
I think we may land here, but I guess I'm not sure where we're there yet. Like where we at least in my mind, and maybe other folks have a more complete view of this, but I guess in my mind, I feel like we may end up here, but we may want a different set of layers, and so not constraining ourselves quite at this stage to a specific model might make sense.
Mm-hmm. I think it works to research this direction integration of FHIR tooling with all the stuff, but still be focused on the main problem we are trying to solve. Yes. So the query the clinical data, yes, and do the analytics and all this stuff. And I think it's time to maybe go a little bit deeper, because we are talking about the transformations, and it would be nice if everybody will understand what kind of transformation. So what should be the principle? We will choose one transformation and throw away another transformation. So I did a small research. So let me share. Okay. Yeah. So if you're talking about JSON, so we understand that the columnar tabular representation is more expressive. Yeah. So you could not do some, I don't know, pass expressions. But so this is a, let me explain. Yeah, so who support JSON, the binary JSON. So most of databases support some type of unnesting. And I think this is the same about columnar implementations. Then most of them support basic JSON paths. That means like dot element, maybe index and array. And so that's the common denominator, to be honest. It ends at the JSON, basic JSON path. So that's what we could expect from most of databases. Are they tabular, like columnar, or JSON? Some databases has support for the JSON path, which is getting standard. So I think maybe in a few years, the more databases will support like asterisk, for example, when you can, it's like FHIR path. When you can go in different branches, yes, or go through all elements of array, and unless I think almost only Postgres support like JSON path filtering, which is kind of like FHIR path do, like the code where system equals something. Most of databases can do this through the combination of unnesting and filtering.
Yeah, that was the question I was going to ask, Nikolai. Are there polyfills available for databases that don't support JSON star and JSON question mark, whatever you want to call that? How do you read that?
Yeah.
What's the correct verbiage to use to describe JSON path star? Is there a better word for that?
Sorry.
So, what does JSON path star really mean? Like, what
does it mean? So it is like in FHIR paths when you go into all the branches of array.
Yeah, but is there a word for that? Right. I don't want to keep saying JSON path star on calls. You know what I mean? Like, is that branch queries? Like, what's the term for that? Anyway, regardless, are there polyfills for it?
Yeah. So it could be polyfill through the unnest and filtering.
Okay, so then
not very efficient,
right?
But in most of cases, probably it will work.
Yeah.
And
I mean, that's ultimately what we need to care about in the end, right? Because some of this stuff is going to ultimately be platform specific, right? Mm-hmm. We're not going to be able to get away from the fact that Oracle's SQL looks a little different, right? That's always going to be a concern. So even if the schemas are exactly the same, when you start writing SQL against these things, you may run into differences, right? Yeah. So if we want to start doing transforms that are going to rely on the ability of JSON path star, and you want to use a platform that doesn't support that, if there's a polyfill that we could create for that, we can say, look, this is going to be slow, right, on this data platform, but it is at least possible until they support it as a first class construct, right?
So let me finish my thought that so potentially we have a transformation which can convert from something like this to just basic path expression. And that could be the principle that we can try to transform until the 80% of queries can be expressed only having basic path expressions. So we can help other technologies. So we can do polyfills and expect that everybody can do something like JSON path filtering, or we can do the transformation on JSON side to express most of queries through the basic ... notation. So, and that could be the principle. So if we will, but we still should figure out what type of queries we want to make work on this transformation, but this may drive us to make decision how many transformation we do. So what elements do we expect should be accessible through the dot, like extensions and stuff like this, yes? Or we go with the polyfills. Okay, and Bashir, so you have comments?
Yeah, sorry, I mean, this is my first time here, so I have enjoyed listening. I don't want to interrupt I'm just wondering, is the goal we want to have a way that, people can specify the query, and then we are trying to create like a layer that query then can be applied on different things? Or are we actually aiming for the actual schema? Because I mean, one thing that I did a few months ago, I actually did a comparison JSON-B on Postgres with our current implementation, which is Parquet and Spark. And in some cases, there were like a huge performance difference. Now, we may ignore that problem saying that, we leave it to the implementers. What we are caring here is that whether you pick like a columnar representation or JSON or whatever, then we are trying to have like a standard query model that then can be translated into these different systems. I mean, are we aiming for that, or are we aiming for the actual schema?
So I think we're trying to chase both. So
wait, can you say more about the performance difference? Which way was that, and where did you find that? Sorry, I just.
Yeah, I wish I actually. I mean, it is still the plan to actually share it publicly. It's in a very bad shape. That's why I haven't. It would be. I'm ashamed to share it right now. But so there were like specific. So I mean, we can go deep in here, but there were specific queries that could be very, very slow on JSON-B. Although JSON-B in many cases was actually performing very well, I was not expecting, but I think because Postgres and has done a great job in binary representation of JSON. But there were also some other queries that it could be very, very slow. And then even trying to add indices to the query, like JSON indices, it was hard to convince Postgres to use those indices. So then, the nice thing about columnar format is, of course, you don't have any index, and most queries were kind of like reasonable. There were some of them were actually slower than Postgres, but the variance was not there. While with Postgres and JSON-B, there was a huge variance, and it could have been that some of the queries I could have optimized it better. I could have better indices. But it was very hard to actually get it to perform well.
Mm-hmm. So let me demonstrate. So this idea that we can transform, for example, extensions indexed by some algorithm and bring it to form like this. Yes. And for example, if we apply this transformation, so the most of databases, columnar, JSON-B, will be able to run this query. Yes. So we can create very simple SQL templating with a macro, which will be replaced with a database specific expression, but most of them in some form supported. And usually if we are talking about accessing element, it is efficient in most of implementations. Yes. In binary JSON, accessing element in binary JSON is this almost the same like speed of accessing the column. Yeah, I'm pretty sure because my friends developed this feature in Postgres. So,
It's a, and to be clear, that that's not the column access speed that's the bottleneck there. It's the disk I/O speed, because in a JSON model, like each row is like stored row after row after row, whereas the column we can do a single disk scan in a sequential read that can read many millions of records. So there are some fundamental differences there, for at least for some classes of queries, are going to yield wildly different performance, to Bashir's point. So I think that's where it kind of gets kind of subtle. Like I'm not questioning the performance or efficacy of the JSON representation in these databases, but it is making trade-offs, and some of those trade-offs are pretty material to some analytic workloads.
Yeah, agree. But yeah, if we get back to the principles of transformation, so we can be very aggressive to try to bring almost everything to these simple path notations. So that could be one strategy. Or we could be very minimalistic in transformation and still decide that unnesting and filtering or JSON path support may work. And this is kind of options we can think. Ideally, it would be nice to have one representation for don't have optional transformation like we discussed before. So if we are talking about portable queries, so then the representation should be almost the same, at least logically the same in all databases. So, and that's my question: are we going to be very aggressive to try to bring a lot of different implementation of databases? And that could be the option. Or we can be not very aggressive, but then we will use extra features like JSON path support or nesting with filtering and stuff like this. If we do this, so potentially almost every database existing like modern will be able to run such type of query. Maybe not efficient, yeah, but we'll be able. And you always will be able to define flattened views, and this flattened views will have statistic and all this stuff, and it will work, and you can build indexes on flattened views, and the whole machinery will work. And that's still the question: are we going to be very aggressive to do this and define the transformation and try to convert all the arrays, which are essentially maps, and index them by something? Or I still don't understand from my own where we should stop with the transformation.
Yeah.
I want to re-echo Josh's point, is that we need agreement on the problems that we're solving, and it'll help give you, Nikolai, and us as a group some answers on how far should we go. Looking at the time, I think it would be useful if folks defined the use cases they'd like to see addressed and brought them into the next meeting. Starting with that base will enable us to go forward.
Mm-hmm.
Just a bit of homework for everybody.
I think this homework was done multiple times by most of these people. So I understand that in a specific case, you are usually very aggressive. Yes. So, or if you have like JSON path in Postgres, you don't need this. Yeah. For example, for Postgres, you don't need to do most of this transformation because it has advanced support of JSON path, and expressions can be indexed. So potentially you don't need this. But if we want to target like Oracle guys or MySQL or something else, so then this transformation will really help to implement.
And this is the perennial problem, right? It's, do you normalize or do you not? Right? How deep of normalization do you go? Mm-hmm. There's not usually an objectively correct answer for every use case, right? In some use cases, having a deeply normalized database where everything is broken up into indexable collections and all that would be highly useful. But in a lot of cases, it won't. To me, I think the trade-off really comes down to, and the reason we're using JSON in the first place is that it's a trade-off between ease of writing queries versus potential performance gains, right? That's how I see it. Maybe I'm wrong, but usually in SQL, when you're creating tables, you choose to normalize because you'll gain some efficiency with indexing, right? But it makes your queries more complicated because you have to start joining and they become very ugly very quickly. A purely normalized database is a real pain in the ass to work with in a lot of cases, right? So I don't know if we're going to be able to arrive at a perfect answer to that question. We're going to have to make some calls here and there, right?
Yeah.
And I think the only way we can make those calls is to understand how FHIR is used, how common certain constructs are, how often, like, take a look at a complex resource like a claim, right? How often are you actually unraveling these things, right? Because a claim is a collection of collections of collections of collections. For something like a claim has tacit relationships between its things, right? So it's got an item component, and that item component has a diagnosis list of numbers that are supposed to be indexes into the diagnosis component and so on. Like those types of resources, it makes a lot of sense to do that type of thing, because then you can do proper indexing joins and things like that. But for other parts of FHIR, it may not make as much sense.
Then
So, yeah, I think people have to go, so we probably need to end it. I guess one homework thing that we could think about, and we can reflect this again on Zulip as well for people who are missing it, but I'm wondering, like, it's very hard to talk in the abstract about all of these things. I think we had a good discussion and brought up a lot of points, but I'm wondering if we want to pick one very, very narrow transform and present it at the next meeting and then discuss it in the context of all these questions. So how would it work on tabular data? How would it work on JSON data? You know, would this be required? What level would it be at? And just kind of work from there so that we're talking about something concrete. Because I think people brought up a lot of really important points, but it's hard to land somewhere without saying, like, is this in the spec? Is this out of the spec? So if we start with a couple specific cases that are narrow and cover a very specific area, then we can say this one's out, this one's in, this one we want to defer, and start to, like, kind of take these ideas that we're talking about portability and layers and different representations and make them concrete. That would be my suggestion about maybe trying to move us forward a little bit. But
I like that a lot.
okay, so we are out of the time, guys. Yes, and I would like to say, if it's discussion, maybe not use Zulip, but use a GitHub discussion, so it will be preserved for the history. So let's discuss specific topics, at least for discussions exist. So
Use Confluence, Nikolai?
okay.
You don't want to use JIRA tickets?
No,
text message thread.
What we found that if it's issue, it is closed. If it's Zulip, it's lost in all these thousands of messages. If it's discussion on GitHub, so it can be open and show the progress and the evolution of the decision. And that would be nice. That would be nice for the FHIR spec, for example, because sometimes some strange stuff appears and you don't know what's happened. Yes, what meeting was, why the guys decided this, and you just know this after the release. So that let's try to keep it, yeah, for the history. I mean, all the discussions. Okay, guys, thank you so much. So see you next week.
Yeah.
On Zulip.
Yeah, thanks.
Bye,
guys.